Hi, this is Aaron Check, and this video is for Chem 110 Lab Section 7. Okay, so in the experiment we started off with shavings of copper, and they were sitting in a 250 milliliter beaker, and then we added 4 milliliters of nitric acid to the copper shavings. Now at this point, nitric acid or nitrogen dioxide, was being given off from the reaction as a brownish brick red gas. The solution was then left with a bright blue clear solution, also known as copper nitrate. Write that down, copper NO3. And then, which is soluble in water, which is how we get the H2O here in the equation. Next, sodium hydroxide was added to the copper nitrate solution, and it became a viscous, cloudy, insoluble solution with a royal blue color. This is known as copper hydroxide. Sodium hydroxide was also a byproduct of this reaction, but we couldn't tell because it shows up as colorless as it dissolves in water. So we have it was known to be there because of the reaction in the equation, so you can see that this Na goes to here, and then this OH goes to here with the copper from here, and then what's left over is this, so this comes to here, and that's how we get this. Heat was then applied to the solution, and a black substance that was viscous and had appeared out of the reaction and settled at the bottom of the beaker. That black viscous substance was copper oxide. So copper oxide. Water was still above the copper oxide, and we decanted the water twice to get rid of any byproducts like the sodium nitrate. So that's why that is here. Alright. And then sulfuric acid was then added to the copper oxide solution, which turned the black substance into a clear blue homogeneous solution, which was later found out to be copper sulfate. So let me write that down. CuSO4, which is copper sulfate, and since it's soluble in water, H2O is still found in this reaction. This could also be determined by the equation, because if you take the copper oxide, see the copper goes here, and then we get the sulfate from here, and then the oxygen comes with the hydrogen right here, which makes H2O. Alright? And then zinc was added to the copper sulfate solution and was stirred while the reaction occurred. The reaction that did occur was the formation of bubbles in gas, which was H2 being given off from the reaction. The zinc turned into black chunks, and then later on to a red color. This was copper, as the solution went from clear blue to completely transparent. So this is the copper that it turned into. Right here, it's in the beginning of the cycle. Zinc sulfate is colorless, so we cannot tell using the eye that it is present, but by our calculations from the equation we can tell. So zinc sulfate goes there. See, because the copper goes here, and then the zinc comes with the sulfate to go there. And there's also some over here still. The zinc sulfate was then decanted from the water, or decanted from the red copper, excuse me. Experimental error that could occur in this experiment and giving a higher percentage than 100% would be the fact that the solutions in this experiment went through many stages of decanting. Although that is not 100%, decanting is not a 100% guarantee that all of the byproduct substances have been washed out. So there still might be some zinc or some sodium nitrate still left in this copper. We're not sure. We can't tell unless we actually broke it down. But yeah, that's how it could still be in there. Another experimental error that could result in a yield of less than 100% will be reactions that are incomplete or competing that we don't know of. And my references are, I used the Chemistry 110 and Foundations of Chemistry Laboratory Manual, University of Mount Union Alliance, Ohio, 2019, to do this experiment, and I used ThoughtCo percent yield definition and formula to find out more information about experimental error.